Welcome to the future of factory automation. This program is a broadcast of a Japanese podcast that has been translated into English using Notebook LM. Today, we're diving deep into something pretty fundamental to making factories really work, the structure of control panels, or as our Japanese sources call it, segyoban no kucho. We've got this really interesting translated discussion here. It's between two individuals from a Japanese podcast, and well, they both clearly have a lot of real-world experience. And for you, our listener, the learner persona, we often talk about this, is basically a shortcut to understanding how experts are thinking right now about these systems and maybe where they're headed.
Yeah, what jumps out right away is how different their perspectives are, or at least their focus. One speaker is definitely coming at it from the hardware side. They're talking PLCs,
Yeah.
the controllers, bus architectures, network topology, really the physical layout. They specifically mentioned that their main thing is figuring out the system's physical shape, the configuration.
Okay, so this person thinks in terms of the physical bones of the system first. Where does everything go? How does it actually connect up? And they made an interesting point about software too, didn't they? Like, they deal with it, sure, but it sounds like it's often driven by what the hardware needs. Like that example, if you want PLCs spread out everywhere, well, the software's got to support that specific hardware setup.
Exactly, and it actually led to a bit of clarification in their chat. The other speaker apparently thought, maybe based on like online stuff, that this hardware person was really deep into software. But nope, the correction came back. It's always linked back to those hardware structures and sometimes the headaches they cause.
Right, a real hardware-first approach then. They laid out their process, figure out the ideal physical structure first, what bits need to talk to what other bits, and then sort out the software to make it all happen.
And what's really interesting there is they admitted sometimes the software you can get just won't let you build the hardware setup you want. It
What?
really shows how hardware and software aren't separate tracks in this field. They're constantly bumping up against each other, possibilities versus limits.
Okay, so that kind of sets the stage. And then the conversation shifted more towards the future, towards the ideal control panel. And one speaker just drops this idea, banless.
Hmm.
Now, ban, meaning the control panel box itself, right? The enclosure.
Yeah, exactly.
So banless is this vision of, well, getting rid of the box, or at least seriously shrinking it. That feels like a pretty big mental shift.
It really is. It points towards potentially much leaner, more flexible automation setups down the line.
Yeah.
But they also kept it grounded, talking about what's available now. Things like modular designs, I mentioned Riddle, where you can kind of click together panels like building blocks. Very adaptable. And they contrasted that with, say, the more traditional European style of often having these big centralized panels.
So different ways to skin the cat, basically, how to house all the controls. But when they dug into what makes a panel design good, what kept popping up?
Flexibility. The ability to add stuff later without tearing everything apart. That seemed absolutely key.
Ah, seamless expansion. Makes sense in a factory that's always changing.
Definitely. They use the example of coupler-based I/O systems, the input-output modules. With a coupler system, you can often just clip on another module if you need more inputs or outputs. Simple.
Right, much easier than trying to, like, jam another Denon rail device into a panel that's already packed solid. We've all seen those.
Exactly. So a good panel, in their view, is actually designed with that rearrangement in mind. You should be able to physically move components around, assuming the wires reach, of course, to make things easier later on.
That sort of built-in wiggle room sounds incredibly useful, but that led them straight into the problems with current panels, didn't it?
It did. And the big villain seems to be space constraints, or rather, how panels are treated in the overall machine design. Often, the machine needs to be compact, and the control panel gets squeezed into whatever space is left over. It becomes an afterthought.
Yeah, that old problem. Just stuff it in there.
Mm.
And that means compromises, right? Less room for future growth, harder maintenance.
And forget about things like built-in redundancy. The idea of designing a panel with backups from the start often just goes out the window because compactness is king.
Okay, so this space crunch is a big part of why that bandless idea is so appealing.
Precisely. The thinking is, if you use components rated IP67, meaning they're tough enough against dust and water to sit out in the open factory environment.
Right, no need for the protective box.
Potentially, yeah.
Yeah.
You could maybe eliminate the enclosure entirely for some things.
So where does that work now? And
Right.
where are the roadblocks?
Well, they seem to think for the low-power stuff, the 24-volt control circuits, it's mostly doable today. Technology's kind of there. The big hurdle is high power, especially circuit breakers. Apparently, getting IP67 breakers that can handle serious current just isn't straightforward yet.
Okay, so the main power distribution is still tricky. What about other power-hungry things, like servo drives?
Similar challenge. They mentioned some companies, Beckhoff, I think, do make IP67 servo drives. But often those drives still need separate bulky power converters, which, guess what? Still need to be housed somewhere, probably in some kind of enclosure.
So not quite bandless yet for the whole system?
Not entirely. They mentioned the B&R 8 Coroll system, too. It has remote I/O you can place out in the field, but again, often relies on external power units.
Got it.
Hmm.
So the pure panelless factory isn't quite here for every application, but this whole discussion, it naturally led into the economics of it all, the business side.
Yeah, this is where it gets strategic. There's this prediction, maybe a warning, that the traditional business of just assembling control panels, it's going to get less and less profitable.
Ouch. So what's the answer then?
The thinking is you have to gradually move towards these more distributed, maybe partially bandless approaches. It's an evolution. Panel builders can't just be assemblers anymore. They need to be more like system integrators, offering more design expertise.
That makes sense. We do see panel builders getting into robotics integration and things like that.
It's happening, and it's driven by these pressures. Panel prices aren't necessarily dropping off a cliff, but builder margins are getting tight. You've got rising costs for materials, labor, but they can't easily pass huge price increases on to their customers, the machine builders or end users, because they're often working on thin margins too.
It's a classic squeeze. Costs up, prices sticky.
Exactly. So this pressure makes looking at radically different, potentially more efficient architectures, like bandless concepts, not just interesting, but maybe necessary for survival long term.
Okay, so the economic pressure is there. But what's actually stopping everyone from just switching over? What are the barriers?
Well, cost is a big one, as you might expect. Technologies like, say, Ethernet with integrated safety or EtherCAT, especially in those rugged IP67 formats,
Yeah.
they just cost more up front.
The components themselves are pricier.
Right. And if that extra cost doesn't directly make the machine run faster or more accurately, it's a hard sell. You've really got to show a clear return on investment. Where's the payback?
Makes sense. You don't spend more unless there's a clear win. But they did talk about one potentially massive win, didn't they? Lead times.
Oh, yeah, that was huge. The idea that if you could eliminate a lot of the panel design, build, and wiring time, that could slash lead times dramatically. They weren't talking about shaving off a few days. They were suggesting maybe going from, say, 30 days down to almost nothing for that part of the process.
Wow. Okay, that would be a game changer, a huge competitive edge.
Absolutely. Far more impactful than just tweaking things a little.
So how do you get there from here? It sounds like small steps, proving the value along the way.
That seemed to be the consensus. A gradual, phased approach. You have to carefully calculate the savings, less wire, less labor time, faster commissioning to justify the higher cost of the new IP67 components or whatever technology you're adopting.
Prove it works on a smaller scale first.
Yeah, and then maybe work towards standardizing those approaches once they're proven successful. That could help bring costs down eventually, too.
It was really interesting hearing one of the speakers talk about their own long-term vision, almost like hoping their current job becomes obsolete because things get so efficient. That's quite a
It
perspective.
really is. Quite forward-thinking.
Yeah.
And it seemed rooted in this belief that for Japanese manufacturing to really compete globally, especially against Europe and the US, they have to embrace this kind of change, drive efficiency hard.
It's bigger than just control panels then. It's about overall production speed.
Exactly. Reducing lead times across the board.
So while maybe fully bandless isn't common yet, are things actually changing on the ground in Japan? Are they seeing progress?
It sounds like it. They mentioned the use of remote I/O blocks, the IP67 ones, is definitely increasing. That alone cuts down on the need for lots of traditional junction boxes scattered around.
Okay, so steps are being taken.
Yeah, and adopting newer tech like I/O Link helps too. That's a communication standard that simplifies wiring sensors and actuators. But again, cost is always lurking in the background as a consideration.
Right. Now, the conversation took a bit of a turn towards the end, didn't it? More about the people, the image of factory work itself.
It did. There was this sense that in Japan, maybe, factory work doesn't always have the same, I don't know, glamour as maybe the IT sector or other industries.
Yeah, perception issue.
And they brought up this idea of fostering factory pride, trying to build up the sense of value and accomplishment in manufacturing roles. A real desire to make jobs like equipment design, electrical wiring more attractive, more aspirational.
That feels really important. If new people entering the workforce don't see a desirable career path there, That's a long-term problem.
Absolutely. I talked about needing better pay, better working environments, clearer career paths, making it a place where people feel they can achieve something significant.
And they mentioned this isn't necessarily just a Japan problem, right? These kinds of perception issues might exist elsewhere, too.
Yeah, they acknowledged it's probably a challenge in many industrialized countries. Japan isn't necessarily unique in that struggle.
But there was this underlying worry, wasn't there,
You.
about things being okay but not great,
Yeah.
a sort of lukewarm state.
Yeah, danger of stagnation. Not a crisis right now, maybe, but a slow drift if things don't change proactively. Like,
Hmm?
the industry might be stable for the next 10 years, but what about beyond that? Competitiveness requires action now.
And that seemed to be the motivation behind their own efforts, like that study group they mentioned.
Exactly. Trying to drive change, collaborating with others who think similarly, and, crucially, trying to prove the benefits within their own companies first.
They also pointed out an interesting potential advantage for Japanese companies having those internal production departments.
Right. Unlike maybe some places where more is outsourced, having production in-house means you can potentially test and implement these innovations more directly from the ground up.
But they were realistic, too, acknowledging the internal pressures, like procurement always pushing for lower costs.
Yeah, the classic tension. It has to work for both sides, the people buying the automation and the people building it. Ideally, efficiency gains should lead to better profitability for everyone, ultimately boosting revenues too.
It sounds really complex, trying to balance everyone's interests when you make these kinds of fundamental changes.
For sure. And they didn't pretend to have all the answers. They're very open about that. But the commitment to keep pushing, keep discussing was really clear.
You really got a sense of their passion for the industry's future. It wasn't just technical talk.
No, definitely not. It was about ensuring manufacturing stays strong and competitive.
Absolutely, a continuous push for improvement. Which actually brings us to our own reminder. Posting 200 daily episodes, please follow and comment,